Okay, so I apologize. The other room, for whatever reason, the dot cam wasn't picking up, and I want to make sure it's in the recording. So I'll pick up where we left off yesterday. So we'll kind of finish up Module 1, unemployment. We'll jump into Module 2, which is inflation today. So just a couple of clarifying things before we get going. I have that Module 2 reading. It's not due today like it usually would be, where it's due before we start covering, just because yesterday we did a lot of syllabus review. So that is set to be due before we start class tomorrow. So you need to have that module reading, that first one done by the time we start class tomorrow. So you can have it set to be right at 11:15. We're going to have this daily quiz today, so it should show up to you now on Canvas. I might have misspoke last class, so I want to make sure. I think I said it was due the following day. Given your schedules, the daily quizzes will actually be due before class, 2 class periods after. So the one that we go through today won't be due until before we start class on Thursday. So you guys have kind of, about 48 hours to get on. If you can't watch it live, watch the recording, answer that daily quiz. You'll have about 48 hours to do so. Now, if you're here live, I would suggest when we start covering this in class, I would then open it up to kind of work along with me. Okay. Also, we're kind of looking at the slides we'll transition to today. So we've got the Module 1 slides that we're using from last class on unemployment. We'll eventually, about 30 minutes into class, jump to inflation. Okay. Any other questions before we kind of jump into things here? Keep an eye on the chat here. Okay. All right. So we'll pick up where we left off. So we're kind of thinking about the unemployment rate versus the underemployment rate and these different measures that gave us some level of how healthy the economy was based off of the unemployment rate. Okay. So what we're going to do today is look at a couple other measures of health of the economy. So the first one we're going to look at is the labor force participation rate. So our labor force participation rate, I'll kind of shorthand this, LFPR. It's going to be percent of our what we call civilian non-institutionalized population, or essentially everyone over the age of 16 who could be working. So this is going to be different than the labor force. Yes, I will make sure once we start it, I will let you know so you can pop it up. I think it's got 10 minutes, so it'll take us less than 10 minutes to kind of go through it. So unlike our labor force, this CNIP, or civilian non-institutionalized population, will be everybody over the age of 16. So this doesn't matter if they're looking for unemployment, if they're looking for employment, they're underemployed, they're discouraged workers. It includes everyone over the age of 16. Our labor force still has the same definition, where it's going to be anyone who is employed or unemployed who is actively searching for a job. Okay. So we think about here, right? Why would lower rates not necessarily be bad? Well, even if we have a higher population, right? If there's more individuals who are choosing not to work, that's not necessarily a bad thing. That could be because they're staying at home. That could be because we have more individuals retiring. And so it's not necessarily the lower rate is necessarily bad, but it does give us somewhat of a measure of how many of our civilians, right, the population, how many of them are entering the labor force. Generally, if that's higher, we're going to have higher levels of output. We're going to have higher levels of income for individuals. And so generally, a higher labor force participation rate would be considered good, but it's not necessarily a bad thing if it's a little bit lower. Right? So this is the idea. If we have an aging population, and birth rates are decreasing, we're going to see that our civilian non-institutionalized population actually goes down, even if the labor force falls a little bit. Kind of the ratio of those two, we could end up with a lower labor force participation rate. And it's just because we have changes in our population. Fewer people who are willing and able to work would decrease this ratio because we wouldn't have as many people searching for a job or either employed or unemployed, but our population would remain the same. So if I have kind of this example, we'll kind of work through it and think through how these numbers will play out. So I'm going to start out with a labor force of 1,000, population 1,500, and we're going to think about what if there's people who age out of our labor force. Okay, so they're still going to be part of our population, but not part of our labor force. So what we'd be thinking about there, if I'm calculating my labor force participation rate, it's the number of it's our labor force, so the number of employed and unemployed individuals divided by that population. You can essentially think about it that way. And I moved rooms, so this is not, where's the screen mirroring? It's yesterday. Here we go. Sorry. So if we had in our example, we had 1,000 people in our labor force, 1,500 people in our population. Similar to the unemployment rate, we multiply this by 100 to kind of give us in percentage form. This would be at what, like 66.6%. Okay. If we have 250 people drop out of the labor force, right, our new labor force would be 750. Our population, though, hasn't changed. Just because they're not in our labor force, they're still considered an individual in our country or economy, and so they would still be included in that CNIP. So here, if we have that occur, we'd end up with a labor force participation rate of 50, or it's went down, right? Now, is that necessarily a bad thing? Well, if these 250 people are just retiring, right, that's not necessarily a bad thing, or this lower participation rate isn't necessarily a bad thing. It just means we have an aging population. Okay. Now, what if instead we think about we have discouraged workers? Okay. Well, everything would work the exact same, right? So whether or not they're retiring or we have discouraged workers, we still see a reduction in labor force of 250, and our population hasn't changed. So it's kind of hard. It's not a perfect measure because we really can't differentiate between are these become, discouraged workers who are just giving up, searching for a job. It also wouldn't just, distinguish that between do we just have people retiring? Now, what if instead we have a slightly different example? So we're going to start out with those same numbers, but let's think about what if we have decreasing birth rates, right? So in this next example, I'm going to think about what if I don't know, think about, this is kind of sad, but 100 people die and we only have 50 people who are kind of aging in to that civilian non-institutionalized population. So we've got 50 new people who are turning 16. We've got 100 people who are dying in our economy, right? Well, starting out from those same numbers, we now have, let's assume, right, that the individuals who are dying weren't part of the labor force before, right? They weren't working, they were older. And so our labor force has 50 new individuals, right? So we can kind of think about, even at its most simple form, what if these people are still in school and they're not working? Okay, so we're going to assume that we've got 1,000 people in our labor force. Hasn't changed, right? These people aren't working. These people weren't working before. Well, if I have 100 people die and 50 new people aging into my population, this actually would reduce my population, but leave my labor force unimpacted. We multiply this by 100. I think here we get approximately 69% there. So this kind of just goes to show if we have decreasing birth weights, we're going to see that labor force population increase. But it's not, once again, it's not a perfect measure. It's not necessarily a good thing because it's just coming from the fact that I have more individuals who weren't working before and they're now just not part of my population. Now, what if instead we didn't have we didn't have these individuals that weren't working die? We have the same kind of scenario, but in scenario 2, let's say everybody that kind of leaves our country, or I said die here, technically they could just, migrate or kind of, leave the country, go live somewhere else. Well, if those 100 people were in our labor force and employed before, and let's assume that these 50 new people are going to kind of enter it, right? Well, if I start out with 1,000, right, I lose 100, but I gain 50 individuals who are now employed, okay? Down here, I had 1,500 people before, I lose 100, gain 50, right? Well, my new labor force participation ratio would be what? 950 here over 1,450, right? So if the individuals who are leaving, right, that population are kind of a higher amount than the people who are joining it, even if they're all employed, this would still give us, and I forgot to multiply by 100 here, this would still give us a labor force participation rate that is no longer increasing, but it's now decreasing, right, from what it was before. So we can start to think about these different scenarios. You know, in reality, it's going to be a more complicated calculation because we would need to know, are the individuals who are leaving the population also leaving the labor force? Are the people joining the population also joining the labor force? I won't push you quite that far. I would kind of simplify to think about what if we had like scenario one, where all the individuals joining and leaving were not employed. Scenario two, all the individuals leaving or joining our population are employed. Okay. Any questions on anything here before we keep moving? Okay. All right. So the next thing we're going to think about is what if I had this broken down by age, right? So I kind of think about it here. The labor force participation rate tends to be kind of higher for individuals who are older, right? When you're 16 and 19, many of those individuals are still in school. So you can kind of see this broken down by different age categories. It's going to be lower for individuals who are younger than for individuals who are older. And then after a certain age, people start to retire. We see for those higher age categories that labor force participation rate actually goes down. So if I took the average here, I've got about 62%. Individuals who are younger have higher rates of labor force participation. Older individuals have lower rates. So what happens if I start to have more people who are kind of aging into that last category? Well, I'm going to see that fewer of them are working, but if they're aging in this category, they're still part of that CNIP or that civilian non-institutionalized population. So if I think about what would be happening here, right, it's going to be kind of a similar scenario that we had before, because if I'm thinking about my labor force participation rate, it's the number of people who are in my labor force divided by that population. Well, if the people are kind of older than 65, that average labor force, right, participation rate, the number of people who are in that labor force starts to go down because there's no more people in that older category and not as many of them are working. However, just because they're aging out, right, they're getting older than 55, they would still be included in that CNIP. So as we see individuals get older in that economy, their labor force participation rate is going to affect that average a little bit more, and we would see a decrease. Okay. Now, how could this maybe be impacted differently? Well, if we didn't just have the same people in our economy getting older, right? If we saw more people migrating to our country, that's not only going to impact the labor force, it would also impact our population. And so there, the answer would become a little bit more difficult or complicated. But I'm just kind of going to, trying to show you here that as we have older populations, more people are still included in this CNIP, but they're aging out of the labor force. So what's going to happen if we have more people in this category? It's going to pull that average labor force participation rate down. Now we have another measure, which is our employment population ratio, which is not looking at the labor force, but it's looking at what percent of our population is employed. Okay, so this is going to be kind of similar. It's going to tell us similar things that the unemployment rate would, but we're now kind of looking at the reverse side of things. We're looking at employment. Okay? So what happens if I have relatively low population growth? But I have, individuals who are kind of, think about it this way. If I have low population growth, I'm not replacing all the old people in my population, so my population is going to start to decrease, right? So even if I have the same number of employed individuals, if my birth rates are lower, that's going to decrease that population, keeping the same number of people employed. That would decrease my employment population ratio. So if more individuals, were dying and were not employed, that wouldn't really impact my employment rates very much, but because birth rates are low, it's going to decrease. I got my animations here. There we go. Decrease my population, leaving the number of employed individuals relatively constant, which would increase that employment population ratio, right? A lower denominator increases this overall fraction. Okay. So these are just different measures of the health of the economy in terms of employment. They tell us slightly different things, but this is one of the ones that you'll be expected to calculate. Okay? And think about how population growth might be related to that. Okay. Any questions before we keep moving here? So now kind of think about how do we take unemployment and break it down into different categories? Okay? So we've got different types of unemployment. The first one we'll think about is frictional, right? Seasonal, structural, and cyclical. So we'll jump into each one of these a little bit more in depth here. So frictional unemployment is going to be people who are just in between jobs, right? This can occur. It's not that they are necessarily they don't have skills that are being valued by the labor market. It's just that they're moving in between jobs. Maybe if they even have a job lined up and doesn't start for another 2 weeks after they quit from their other job. So this is going to be frictional unemployment. This is just the nature of people moving in between jobs. Okay? So they could be searching for better job offers. So they might be kind of holding out. They might be able to work for someone, but they're kind of holding out for a slightly better paying job. This is just frictional unemployment. Okay, so we refer this to as short-term unemployment, right? We don't expect it to last forever. Eventually, these individuals, even if they're holding out for a better job offer, they'll eventually kind of join the individuals who are employed. Now, this isn't necessarily a bad type of unemployment because we want individuals to end up in jobs that match their skill level. If they simply took a job, the first job that was available to them, what might we have there? Well, if they take a job that's below their skill level, we would actually have more underemployment. Okay? So frictional unemployment is not necessarily a bad thing. Okay? These individuals are holding out for a better job. They eventually will get one relatively quickly, which would then cause our unemployment rate to be lower, right? However, if they just took the first job available, yes, they're no longer unemployed, but they would be underemployed. So the unemployment rate there wouldn't change, but our underemployment rate would actually increase if they didn't hold out for a better job. Really this is going to be kind of impacted by quitting versus being fired. If I quit, that potentially means I'm just looking for a better job that matches my skill levels. If I'm fired, that likely means it's not that I'm holding out and looking for a better job. There wasn't a job available for me any longer. Okay. We also have seasonal unemployment. Now, generally, this is kind of a subcategory of frictional unemployment. And this would be something like seasonal changes that cause people to be unemployed. So for instance, right, if I'm growing certain crops, they don't grow during certain times of the year. If I'm being employed by some large scale farming operation, I might not have a job in the winter, but I would have one ready for me as soon as we can start planting again. Or I just went to up in Michigan, there's like these little, touristy towns along Lake Michigan. And in the summer, there's all kinds of fun, right? There's more people working at these restaurants. There's little gift shops that are open. In the winter, not as many people want to visit Lake Michigan because it's very cold, snowy. And so the number of workers they hire in those months is going to be lower. Right? So this is what we call seasonal unemployment. These individuals have jobs throughout the year. It's just that in certain seasons, they don't. Okay. Also, you can think about reverse example, like maybe people who are working to plow snow. They would have that job in the winter, but not in the summer. So typically, there's going to be some seasonal unemployment. Now, many individuals might, plow snow in the winter, and they might work for a farming operation in the summer. And so there we're kind of bouncing back and forth between seasonal jobs. That's why we have this frictional, it's kind of a subcategory of frictional unemployment. So a lot of the unemployment rates that you look at from government agencies, they adjust for this seasonal unemployment. Okay. So if you adjust for this seasonal unemployment, how is that going to impact our unemployment rates? So we can think about here. Let's assume that we started out with this scenario and we're measuring kind of that unemployment rate. And it's currently, I've got 3,000 people unemployed and my labor force is 4,000 individuals. This would give me, these are wild numbers, right? Hopefully unemployment is never 75%. I'm just trying to use some nice easy numbers that we have to work with. So we start out with a really high unemployment rate. However, if we adjust this, right, maybe there's 1,000 individuals, right, who were part of our labor force and they were employed, but now because that job no longer exists in that season, they have to wait until, you know, a whole year to kind of start working again. If we adjust for this, right, we would kind of take those same 3,000 individuals and let's assume 1,000 of them were employed because of whatever season it was. If we adjust for this, we have what, 2,000 over 3,000. We actually see once we adjust for those individuals who are employed seasonally, our unemployment rate isn't as high as before, it's actually lower. So anytime we adjust for these seasonal kind of unemployment individuals, we're always going to end up with a lower seasonally adjusted unemployment rate. Okay. And we can think about why. It's kind of like our discouraged worker example from the previous class, because when we adjust for seasonal unemployment, we're taking those individuals out of our unemployment category. So you can kind of think about these, we're seasonally unemployed, but we're also taking them out of our labor force. Well, because that unemployment number has to be less than our labor force, right? Our labor force includes both employed and unemployed individuals. Subtracting that same value from our numerator as we are from the denominator is always going to be a larger percentage change. So we're always going to be seeing that reduction in our unemployment is always going to be much larger than the reduction in our labor force, which that means the change in our numerator is going to dominate, and we're going to see overall unemployment rate goes down. And I'm leaving off the multiplied by 100 here, but kind of thinking about this. So should we subtract? Yeah, when we're adjusting for these seasonally, we're assuming that they're no longer actively searching for a job, right? They're out of the labor force. They're waiting for the next season to occur where they then can pick up where they, you know, the job that they were working before. So yeah, we get subtracted both from our unemployment and our labor force if it's seasonal unemployment. Okay. Any other questions on that before we keep moving? Okay. So the next thing we want to do is think about the other two types of unemployment that we would have, which are, there we go, structural unemployment. This is going to be people who, it's not that they're holding out for a better job offer, it's that they don't have the skills to get a job that is currently available. Right? So these are people who are going to be unemployed, and they're unemployed because, you know, if most jobs are kind of transitioning to, you have to have some level of understanding of, let's say, better technology. So I don't want to employ you if you don't know how to use generative AI to actually be a more effective worker. If you don't have that skill set, the jobs that are available are not going to be ones that you can get, right? So there's structural things that are changing in our economy that are causing some individual skills to no longer be valued, and they're going to remain unemployed. Okay? So if education levels remain stagnant, or our workers aren't picking up these new skills, but jobs, right, the production that, you know, or the skill sets required by these companies to increase production are requiring higher education levels, there's going to be more individuals who they don't want to hire. And so this would be kind of our example of like structural unemployment. You know, the other one I kind of think about, maybe these TikTok stars, right, or whatever there's, it's not as popular of a thing anymore. And so if they want to get a job, in the social media industry, maybe if that platform isn't being as valued as high as it was before, these individuals can't find a way to kind of earn money. Now, that's kind of a goofy example, right? TikTok and being unemployed. Probably the better example there was that I gave was the use of generative AI and developing that skill. So structural unemployment tends to be pretty bad after recessions because during a recession, companies are attempting to increase their technology, increasing technologies that will increase production, but these new technologies, people might not have the skill level yet to be able to kind of execute them or use them in those jobs. So we would kind of usually refer to structural unemployment as long-term unemployment. These are individuals that if their current education level doesn't match up with the jobs available, unless they change, they're going to remain unemployed. So unless they pick up these new skills or they get higher levels of education, they're going to remain unemployed. So we think of structural unemployment as more long-term. Our frictional unemployment, people were just moving between jobs. They had the skill set companies wanted. They were just trying to kind of find that job. There was some time that it took to match up with the correct job. Here with structural unemployment, there is no job matching them. They haven't increased their skills. So, longer durations of unemployment are typically evidence that we might have structural unemployment and not frictional or seasonal. So the longer durations typically would reflect that we have unemployment rates that are going to increase because those individuals who are unemployed, they're not increasing their skill sets. They're going to remain unemployed for longer, and that's an indicator that we have structural unemployment. And then our final kind of type of unemployment, is going to be cyclical, all right? So even if we have the individuals in our economy trying to update their skill sets, they're trying to improve their skill levels. Anytime we have economic downturns, there's just going to be fewer jobs at certain companies, and so those individuals might become unemployed, not because they don't have the right skill set, because there's not as many jobs for their particular skill set as there was before. And then once things get better, well, now companies, instead of having a lower demand for workers, right? Once they start to see improvements in the economy, now there are more jobs available, and we have the reverse where more individuals are going to be employed. So these are our 4 types of unemployment. I won't ask you too many questions that dive too deep into like identifying what type of unemployment this is. The main thing we want to focus on, A, is that seasonally adjusted unemployment rate. And then also that's the way we differentiate between structural or cyclical and frictional unemployment. Cyclical and frictional unemployment tend to be shorter term or smaller or lower durations, whereas longer durations of unemployment typically reflect there's some structural unemployment that's existing. All right, so those are our kind of 4 categories. We'll kind of use them to now think about our natural unemployment rate. So I put some links in here. They're generally just some data sources. We won't kind of go through them here today. Maybe if we have a little bit of time, I'll revisit them here at the end of class. But for right now, just think about, we've got, we're going to talk about it. You can look at the actual data. So our natural unemployment rate is going to be our unemployment rate that doesn't include this cyclical rate, because our economy had these ups and downs, times that are good, times that are bad. We're kind of thinking about the natural unemployment rate would be, let's say over the course of a year, we know the economy is going to have its ebbs and flows. So we're looking at kind of that natural unemployment rate over the entire year. That would kind of wash out, right, the fact that we have some up and downs during that year in terms of unemployment. So our natural unemployment rate is just going to be structural, frictional, and seasonal unemployment. So it doesn't include this cyclical unemployment. So if I'm thinking about the actual unemployment rate, if we have any type of cyclical unemployment, what's going to be true? Okay. So kind of switch here, and just to kind of make it a little more mathematical, but to give you a way to kind of visualize this, if our natural rate of unemployment is, if I can spell, structural plus our frictional plus our kind of seasonal. Well, the actual unemployment rate is going to be all three of those, but it's also going to include cyclical unemployment. So it's got, and I'll shorthand this here. The same three components as that natural unemployment rate, but it's also going to include cyclical. So anytime cyclical unemployment is anything above zero, what has to be true? Well, these are all the same. Any type of cyclical unemployment would mean that our actual unemployment rate is greater than the natural rate. Okay. The very lowest we could ever see cyclical unemployment be, well, if there's no unemployment, we would have zero. In that case, the natural rate, right, and our actual unemployment rate would be the exact same. But any type of cyclical unemployment that exists, we would see kind of that actual unemployment be greater than our natural rate. Okay. Nothing too crazy there, but just to kind of write that out to kind of give you a little bit more insight into why that's the case, right? Into why that actual employment is going to be greater than our natural employment. So what impacts would economic downturns then have on wages and unemployment? So we can there think about our labor market and how what this is going to look like. So here we go. If we have economic downturns, and this might vary a little bit from the book, so I wanted to give you a nice visualization so that we could think about this. I'm not sure who you took B251 with. Some instructors dive a little bit more deep into the labor market. I tend to. So here, if we're thinking about, I've got the quantity of labor, right? Just like we would have the quantity for any product. Well, instead of the price of a product, the price of labor is the wage that have to be paid. Right? So we're going to have some individuals who want to supply their labor at various wages. As the wages increase, more people want to work those jobs, right? Or want to find a job. If the demand for labor that's coming from our companies, right? If they have to pay higher wages, they don't want to hire as many individuals. So as that wage goes down, the demand for labor, companies that want to hire individuals, tends to go up. So just like any market, where is our equilibrium? Well, that's where supply equals demand. Okay. If we have economic downturns, that means that maybe the same number of people want to supply their labor, but companies, right? If their product, right, they're not be able to produce as much or sell for as much money, the demand for labor would actually decrease, right, during economic downturns. So if that happens, we can kind of think about, here's my new demand for labor. It's now lower. What impacts does that have, right? Well, it's going to force wages to be lower, and it's also going to force the number of workers hired to also be lower. If I have fewer people working, but I still have the same number of people who are willing and able to supply their labor, what does a reduction in employment mean? It means that unemployment has actually went up, right? So any economic downturns would actually cause our unemployment rate to increase. Whereas, what if we had times are good, or not economic downturns, but economic upturns or upswings, that there's a higher demand for labor. Well, if I have higher demand for labor, call this D3, right? What is that going to do? It's going to increase wages, and it's actually going to increase the number of people who are working. Now, it's the same number of people who are able and willing to work, so the same labor force, but if more people are being employed now, in that scenario, when times are good in our economy, our unemployment rate actually goes down. Okay. So this is kind of the link between our labor market, the number of people employed and unemployed, and whether or not times are good or whether or not times are bad in our economy. Like I said, this might be kind of a review for some of you. Any questions on this before we kind of switch gears and start to look at inflation? Okay, so before we start on inflation, oh, here we go. Are all these types of unemployment, they're still looking for jobs? Yeah, we assume that in all these unemployment, the individuals are not discouraged and they're still actively searching for a job. Okay. So next thing I want to go through. So this is where I'll prompt you to the question earlier. Don't pull open and start these quizzes prior to us covering them in class. Otherwise, it's going to be a little bit harder to answer them. So I would now kind of give you the prompt. I would access this daily quiz, right? It should be open right now to everyone who's active and kind of live here. I'd then open it up. We'd look at it together and we kind of work through these problems. Okay? So the first one we're going to work through is assume, this goes back to last class, so a little bit of review here, but assume that the number of unemployed individuals remains the same. However, there are individuals who are newly employed that weren't searching for jobs before. So we have the same number of unemployed individuals, but maybe, the economy saw an increase. There was more people who are now willing to work at higher wages. Which of the following would not be true? Okay. So we're going to kind of go through this and think about, all right, so if we're thinking about the unemployment rate, that's the number of unemployed individuals over our labor force. Okay. If I think about my underemployment rate, that's my unemployed individuals plus underemployed individuals divided by our labor force. Okay. We also have kind of this labor force participation rate, which was the number of people in our labor force divided by our population, essentially. And I think the last one I gave you was what? Yeah, the employment population ratio. So if we wanted that employment population ratio, that was the number of people who were employed over our population. Now, all of these would be multiplied by 100 to kind of make them percentages, but here we're just going to think about directional changes. So we said if the number of unemployed individuals remains constant, but we have new people joining our labor force and they're employed when they join, right? They found a job. They weren't looking before. Now, because wages are higher, they're now going to kind of look for a job and they become employed. So if that's the case, maybe we could go through some easy ones. If these people are employed, that would increase the number of people we have employed. However, they were in the population before they looked for a job and they're in the population after. So this is going to remain unchanged. Well, if my numerator goes up, my denominator doesn't change, that employment population ratio should increase. Now, if I'm thinking about my labor force participation rate, population hasn't changed. The labor force, I have more people joining it who are now employed. Remember, our labor force was simply our employed individuals plus our unemployed. We've got the same number of unemployed individuals, but now more employed individuals. My labor force is going to increase. Once again, numerator goes up, denominator stays the same. I should see an increase in my labor force and my employment population ratio or rate. Now, if I have more people who are joining who are employed, my underemployed and unemployed individuals, once again, remains the same. But if my labor force is now going up, my denominator is now larger, that underemployment rate should be going down or decreasing. And then same kind of idea here with my unemployment rate. Unemployment is staying the same. Newly employed individuals, that would cause my labor force to go up. So we should see that unemployment rate decreasing as well. So unemployment rate in this scenario would go down, underemployment goes down, labor force and employment population rates should go up. So if we're thinking about which is not true, we said the employment ratio will increase. We said the participation rate will increase. Unemployment and underemployment rates should decrease. So the one that's not true would be this one. Okay. Yeah, since they weren't looking for a job before, we wouldn't consider these to be necessarily discouraged workers. In fact, even if they were, it wouldn't change these directional changes because discouraged workers don't count as as part of our labor force. And they also don't count as underemployed. So this is the same, we would have the same directional changes. Okay, any questions on that before we keep moving? Okay. So the second question, we're comparing our unemployment rate to our underemployment rate. Okay. So we're going to do that first, and then we're going to compare our natural rate to the actual rate of unemployment. So if I'm comparing the unemployment and underemployment rates, remember, my unemployment rate is the number of unemployed individuals over my labor force. My underemployment rate, I still have the same labor force, right? Because these individuals are still employed, but when I'm now calculating this rate, the underemployed individuals kind of show up in that numerator. So my underemployment rate and my unemployment rate always have the same denominator, but my numerator now includes the individuals who are underemployed. So my unemployment rate will always be less than my underemployment rate, as long as I have one individual who is underemployed. Okay. So that's going to be the relationship between the unemployment and underemployment rate. And then we really already covered this earlier, but if we think about the natural rate of unemployment and we're comparing that to the actual rate, we said which of these is larger? Well, essentially they both include the same types of unemployment, structural plus frictional plus seasonal. But we said the actual unemployment rate includes all three of those, but it also includes our cyclical unemployment. So as long as that cyclical unemployment is anything above zero, our actual unemployment has to be greater than our natural rate. So if we're thinking about the answers here, the unemployment rate we said was always less than the underemployment rate, and our natural rate of unemployment will also always be less than the actual rate of unemployment. Any questions on that idea before we keep moving? Okay,
Wait,
so
can you repeat that once again?
hold on. The volume is very loud in this room. Say that again.
Oh yeah. Sorry, can you repeat question two again?
Yeah, so we're kind
I
of
like the
looking at
answer.
this.
Yeah.
We said the unemployment rate will always be, as long as we have one underemployed individual, our unemployment rate would always be less than the underemployment rate. Okay. And then as long as we have anyone who is cyclically unemployed, the natural rate would always be less than the actual rate. Okay. We should have another 2 minutes. Kind of make sure you get that submitted. If you started at the same time as me, you'd have that full kind of 10 minutes to make sure you're working along with me and getting those answers submitted. If you're doing this after the fact, you're watching the video, you'd still have, the answers within the same amount of time. Yeah, so it won't show you because people still have time to get on and do these. It won't show you the answers until the due date passes. So if you're attending this live, I mean, it'll, your score will update once that due date passes. Okay? That just kind of my way of making sure that you don't just give answers to someone, they answer the quiz, and then don't watch that recording after the fact. Does that make sense? And all these questions are good. Like this is our first time looking at these daily quizzes. I want to make sure if you have any questions that we kind of get those addressed. Any questions before we keep moving here? Okay, so we'll now jump into, and I apologize yesterday, I had this posted to the main page, but it was for some reason blocked in the files tab. I will double check from here on out that these PowerPoint slides, if they're published here, they'll also be published under the Files tab, just in case you're accessing them that way. So we're now going to start with these Module 2 inflation PowerPoint slides. We'll kind of go through as much as we can get through here in the next, 25 minutes or so, and then we will finish that Module 2 material tomorrow. All right, so let's start here. Right? So Module 2 is going to be talking about inflation. Right? It's likely a word that you've heard before. If we had more people in class, I probably would take a little more time, ask you what, if you heard that basically inflation means that prices are increasing, right? So we've got average prices in our economy for goods and services are increasing. We would call that inflation, right? So I've got some example here where we could look at home prices. I think I've got a graph here in a second, but if you wanted to access the data where that graph comes from, I put a link in here. So if I think about average home prices in the US, if I looked at it graphically, probably not, I guess maybe some of you haven't been alive or have kept an eye on the home price market or real estate market as much as individuals who are older, but trust me, it just every year it seems like they're higher and higher. So we looked here from 1965 to 2025, home prices typically have experienced inflation. Now there's really small times when maybe home prices have decreased, right? That's a good time to buy because in general, if you buy when prices are low, same house is going to be worth more if you try to sell it later on. Now, this isn't a perfect example of inflation because although average home prices have generally been increasing, well, what's also true about new homes? The new homes built today relative to the 1960s have a lot of new features, right? Are likely larger than they used to be. And so we don't have we're not controlling for quality of homes, but if we're just looking at prices, this would be, we consider kind of inflation for this good. The good just is a little bit different, which is it's a house. Okay. So here we've got one good, we see evidence that there's inflation with that good. Okay. Now I have this here broken down a little bit more. We can also think about, well, change this back to my office. Just copying and pasting my titles here. If we think about not disinflation for a second, we'll jump to that next, but we have deflation, right? Deflation. So if inflation is increasing prices, deflation is decreasing average prices. So if we look here, if my y-axis here is measuring the increase in prices over time, from 1997 to today, I mean, what has the most inflation here? What has seen the largest increase in prices? College tuition. That's not a great news for you guys, right? And so college tuition has experienced very large inflation over the past 20, 30 years. Daycare, preschool, medical services, they are kind of, also have significantly increasing prices or inflation. Now, when we look at inflation rates, this is going to be the average over all types of goods, but we could always break this down into categories. So you'll notice here, almost everything we have here, I guess new cars and clothing have remained pretty constant, but every other good has seen an increase in their average prices. What goods haven't seen inflation, but have instead seen deflation? Well, I don't know why toys have, but if we look at computer software and accessories, this kind of makes sense, right? As technology advances, these goods have become cheaper to produce, and generally they're then going to be sold at lower prices. So computers and software, computer accessories and software, they've experienced some deflation. And then also same kind of idea with televisions. And if this went way back, TVs used to be significantly, I was trying to think, I went and I bought a relatively large TV in the last time. I mean, you can get these for like a couple $100s, where they used to be a real TV of the same size might have cost you $1,000 or a couple $1,000s in the past. And so that's another good example of a good that we've actually seen have a decrease in their overall prices or deflation. So inflation, increase in prices, deflation, decrease in prices. Okay. Now, another thing that we can measure is what we call disinflation. So disinflation, we could still see that the average price of goods is increasing, right? We have inflation. However, that rate of inflation is decreasing. So from year to year, maybe if inflation in year one was 5%, but if inflation in year two is 4%, yes, prices are still going up, but they're going up at a lower rate than they were previously. So what years from this graph would I see that have experienced disinflation? So here I've got the measure of inflation on my y-axis, and I've got time here on the x-axis. So notice as I progress through time, let's say we start here. My inflation was, what, 5.5 about. It starts to get higher and higher. Now, once we get up to this point, from about 1980 to 1984-ish, I still have inflation, right? My percent increases in prices are all still positive. However, over time here, the rate of inflation is lower and lower, or I have a decrease in inflation. Okay? So I would say from about 1980 to 1984, 83, we experienced, yes, inflation, but we had disinflation, right? The inflation rate was going down. You can see other periods where it was going down. We still have positive amounts of increases in average prices. So we still have inflation, but the rate is getting lower. Right here, it's getting lower. Here, it's getting lower. Now, this graph doesn't do a good job of showing you one more thing, which I'll show you with some slightly different numbers. But basically, anytime we would see a decrease or a kind of a downward sloping line here, that's evidence that in that period we had disinflation. Inflation is always positive here, with the exception of like this year, it like barely went below zero. So if I asked you what years have deflation, it's really just going to be, looks like 2009, right? There, the average change in prices was just below zero, was negative. Okay. So before we talk about the cost of inflation, I want to give you a different example to think about how we could measure inflation, deflation, and disinflation. Okay. So anytime we have inflation, right? Anytime we're measuring this, if it's above zero, right, this measure of inflation, it would be we have inflation. Okay. If our measure of prices is ever less than zero, we would have deflation, right? If it's negative, our change in prices are going down, or a negative change. Here I can write kind of negative. Well, I won't use too many math here. Here, if we have a negative change, we would have deflation. If we have a positive change in prices, and I'll just be a little bit more specific in what I'm writing out here. If we have a decrease or negative change in prices, that would be deflation. Now, when does disinflation occur? It's when that rate of inflation goes down. So let's think about a little toy example here. I'll write out some years. So not just from a graph, how could we do this using numbers? So I think here's all my time periods, right? So this is kind of the year. And here I'm going to have the measured inflation rate. Okay. So let's say we've got 3.2, 4.1, 5.3, 2.6, 2.7, negative 1.2, and negative 0.5. So this is one there's a slightly tricky thing in this example. So if I'm looking at what years experienced inflation, it would be anytime we have a positive inflation rate, anytime we have a positive change in prices. When do we have deflation? Also, I know I'm pronouncing this, it's just deflation. I say deflation to really make this differentiation between these two. But anytime we have negative change in prices or an inflation rate that's negative, we would call that deflation. Okay. Now, where does disinflation exist? Well, if I'm looking here, the inflation rate is going up from this time period to this time period. However, from 2002 to 2003, we have inflation in both years, but that rate of inflation is going down. So we would call that time period has or is experiencing disinflation. We still have an average increase in prices, but the average increase in prices is less than the time period before. That would be disinflation. Then we go back to here, the rate is going back up, so we don't have disinflation, right? It's no longer decreasing. Now here's where it gets a little bit tricky. So in between here, even though I'm going from inflation to deflation, the inflation rate is going down. Right? So if my inflation rate is going down, I would have disinflation. Okay. Now, would I still have disinflation going from 2005 to 2006? Well, here's where it gets tricky because we have negative values. Even though we have deflation here, what's happening? Is it going up or is it going down? Well, our inflation rate going from negative 1.2 to negative 0.5, our inflation rate is actually going up. We still have deflation, but the inflation rate is actually increasing. So here we would not have disinflation between 2005 and 2006. It's only between 2004 and 2005. It kind of stops there. So we had two time periods that had disinflation. Anytime it was positive, we had inflation. Anytime it was negative, we have deflation. Any questions on that idea? Once again, don't get tricked by these negative signs. A lower negative value, right, is actually that inflation rate is getting closer to zero, so it's actually increasing. So is there a term for when inflation rates increase? For the sake of what we're doing, no. I mean, I think, in general, when we talk about this, there's not one terminology. We would just say that inflation rates are increasing. But when we have inflation rates decreasing, that's just a more specific kind of terminology that inflation rates are decreasing. We call that disinflation. Yes. So that's a good question. Let me make sure I got all these here. Yeah. So we're looking at that graph again. Anytime you see that the inflation rate, right, on the graph, if that line is going down, that was a period of disinflation. So here's disinflation, here's disinflation, here's, these get a little bit weird, but here's disinflation, here's disinflation, here's disinflation, so on and so forth. Any other questions on that before we keep moving here? Okay. So let's next think about what are the costs of inflation, right? I mean, if we just think about this in general, do you think inflation is a good or a bad thing? Well, if prices are going up for consumers, this is going to be a bad thing, right? So we can think about another measure of why is inflation costly to the average consumer, right? I mean, we know inherently higher prices are going to be bad. We all buy things day to day. We want prices to be low. So purchasing power is going to refer to what can I buy? How many goods and services can I buy with the same amount of income? Okay. So if income remains constant, what happens if an economy is experiencing inflation? So I can run through a basic example here, right? So let's assume we start out with a scenario where my income, and just to make these numbers nice and easy, is 1,000. Current average prices, and if it helps to think about just the price of one good, let's say it's $100. Okay. So how many units of this good could I buy? Well, the quantity of this good I could buy is going to be whatever my income is. If I'm spending all of my income divided by the price of that good, the per unit price. So in this first scenario, we have what? 1,000 over 100, or I've got quantity is going to be equal to 10. If we have inflation, right, let's assume that I'm still earning the same amount of money, right? My salary is unchanged, but prices are now higher. Okay. Well, under this scenario, how many units can I afford to buy? It's still my income divided by the price of that good. But notice, before we even make this calculation, if my income remains constant, but prices go up, denominator is larger, I know the quantity should be lower. So this is one thing you can do is before you even make these calculations, in case you like hit the wrong number on your calculator, or hit, I don't know, multiply instead of divide on accident, just from this, we know the new quantity I find should be lower. When I plug the actual values in, sure enough, that quantity is now lower than it was before. Okay. Any questions on that before we keep moving here? Shouldn't be too bad. Now, I have a second scenario in the slides here. What if income changes, but prices change as well? So prices go up, we have inflation, but we also have an increase in income. Okay? So let's assume that we have income doubling, but prices are going up by a factor of 4. Okay? So if we were to write this out, I'm going to start out, call this 1, 2. I'm going to compare scenario 1 to a third scenario, which is my income doubles, but prices have went up by 4. So I'm going to make the calculation first, but then show you a different way of thinking about how you would actually calculate purchasing power. So in this scenario, my income was 1,000. It doubles, but the old prices, or the old price of one good, if it helps to think about it that way, has went up by 4. So I make this calculation, I've got what? 2,000 over 400. Excuse me. And so, did I have this in here right? Yeah. So I've got what? 2,000 over 400. My new quantity should be 5. Okay. Now, there's a different way you can think about purchasing power if you have changes in both income and prices. Instead of having to do the calculation, I could actually tell you whether or not it went up or down and by what the new quantity would be. Because if I'm multiplying here, I could rewrite this as income divided by price and then multiplied by that ratio of how much each one is increasing by. So basically, I would have the same quantity as before, so I could afford to buy 10 units, right? However, because of the changes in income and prices, my purchasing power has now fallen, right? Or it's been cut in half, which gives me that same quantity of 5 as if I actually plug the numbers in. So if you have simultaneous changes in income and prices, the change in my purchasing power, or how many units I could buy with my income, right? I can calculate what that would be. And in this case, it would go down. Let's think about a second scenario. Well, second scenario to a simultaneous change, right? So let's say here, just to kind of all be on here. Let's see if I can adjust this. There we go. Let's say I have a fourth scenario over here where I've got income going up by a factor of 6, but prices are going up by a factor of 3. Well, I could do a similar thing. What is my purchasing power? It's going to be my income, which is increasing by 6, divided by average prices, or the price of a good, which is going up by 3. If I plug these numbers in, I'd end up with what? 1,000 times 6 over the old price of 100 times 3, 6,000 over 300. I can buy twice as many good units as I was before. Once again, I could rearrange this so that I could see what's the purchasing power I now have. It would be my old income divided by the old price, and then multiplied by this ratio of how much income was increasing relative to how much prices were increasing. So my old purchasing power, my new purchasing power should be that times 2. So 10 units times 2 would give me that same quantity of 20 as if I actually plug those numbers in. Okay. So if I didn't give you the original income and prices, but I asked you how much will purchasing power increase by, in this scenario, it goes up by a factor of 2, that ratio of the change in income to prices. In this scenario, how much did my purchasing power change by? It actually went down because that ratio is less than 1. Okay, so it was cut in half here. Went from 10 to 5. Okay. Any questions on that idea before we keep moving here? So just as kind of a check over this concept, what if I didn't tell you the amount, but let's say income goes down and my prices, I still have inflation. What would have to happen to my purchasing power or the number of units I can buy? Well, I calculate purchasing power by taking the income I have and dividing it by prices. So if my income goes down and prices go up, well, smaller numerator would cause the fraction to go down, and a higher denominator would cause the fraction to go down. So I can definitely say purchasing power is going to fall. When I have simultaneous changes in income and prices, if they're both moving in the same direction, there it's a little bit harder, right? I don't know whether or not it's went up or down. I have to kind of look at that ratio of how much each one changed by. But if they're going in opposite directions, I always know what's going to happen to my purchasing power. If I think about a second scenario here, what if income goes up, but prices go down? So I have deflation. Well, if income goes up, prices go down, a higher numerator increases my fraction, lower denominator increases my fraction. So in this scenario, I know my purchasing power is going to, there we go, increase. Okay. So these simultaneous changes, if we ever have things working in opposite directions, we know what's going to happen to that purchasing power. If they're ever working in the same direction, it becomes a little more difficult. We have to look at what that ratio is. Okay. All right. So we're going to leave off kind of here. We'll pick up next class thinking about different measures of prices and increases and decreases. So we kind of started on it today. We'll finish this up next class or tomorrow. That daily quiz, if you're watching this recording after the fact, you need to have that completed before class starts. So at 11:15, before class starts on Thursday. Okay, so I have 2 days to kind of get that done if you're not attending this live. If you're here live, hopefully you pulled it up when we went through it, and that should have been pretty easy to get those answers correct. Any questions before we kind of log off here for today? So I kind of posted an announcement yesterday at my office hours. I had to cut 30 minutes of them out this morning. Once I get back to my office here, it shouldn't take less than 5 minutes for me to walk up to Wiley. I'll start those office hours and I'll have them for 30 minutes, so till like 1:05. All right. If you have any other questions, feel free to email me. Otherwise, I will see you in class tomorrow at 11:15.
Thank you.
Thank you.
Thank you.
Thank you.